to show you a few. I had a chat with a friend. I had a chat with a friend who did interviews with them a while ago, and these are the kind of things he was saying. So there's the elevator system. There's this thing of the priority queue. I don't know whether you've ever dealt with that. And then we have to print out depth first search graph. I think this is depth first.
Yeah, depth first search.
To print, yeah, backtracking.
Backtracking. Yeah.
Yeah, it was on a phone call, so I just wrote things.
Yeah. Yeah.
And then this one is an array with zeros. I think I'm thinking of ignoring this because not really ignoring, but not prioritizing on it because it's arrays.
Yeah. Should be is a little more basic.
Yeah, it should be a little more basic. And then n by n Rubik's cube. So I don't know whether it was. I don't know whether it was something to do with striking out like 3 cells on the cube. I don't know how the cube normally is 3 by 3, right?
Yes. Or well, yeah, normally it's 3 by 3 by 3. Yeah.
Yeah, 3 by 3 by 3. And I don't know whether it's it was something to do with striking out maybe paths on the Rubik's cube. And then there's this about spiral order, printing an array in spiral order.
Spiral order. Okay, never heard of that. But okay.
Yeah. Then we have binary search tree implementation in arrays.
Okay.
Yeah, sounds like a whole new start of life.
Yeah.
Yeah.
You know binary search?
Yeah. I know. Okay. I know the recursion bit of it. Yeah, where so there are two. So you'll get like the tree. So things that are less than the root are on the left side, and things that are more than the root are on the right side. That's the binary search tree, right?
Yeah.
And then you recurse based on what's on the left or right.
Based on like a comparison of the number of the thing you're trying to find.
Yeah. So you compare it with the root. If it's on the right, if it's less, you recurse on the right. On the left, if it's more, you recurse on the right.
Yes.
If it's equal, then you found your guy.
Yeah.
With
different semantics.
So maybe we can get some HackerRank or oh man, this guy. Yeah, maybe we can get some HackerRank or maybe lead code questions that deal with this?
Yeah, maybe.
Yeah.
Yeah, it's hard to explicitly tell what these questions are asking, or some of these questions are asking, but yeah.
Yeah, I know.
Yeah. So,
Maybe lead code, I know you can do a search. Maybe with lead code, I know you can do
yeah. Just going off a Google search on a couple of the ones, I think that might be a question.
so.
The elevator system priority queue.
Yeah, priority queue. So I think he was saying like they will ask like the priority queue question to test on. They will ask on maybe how to design the elevator system so that you maybe demonstrate how good you are with design if you can think of the correct data structure.
Okay.
Yeah.
Okay. Oh, okay.
Yeah,
That kind
so
of makes sense.
yeah, so they will throw a problem like it was just saying they will throw a problem like, for instance, if you're asked to design, okay, they give you the properties of the elevator system, and then they tell you can you do maybe can you design and maybe do the system or something.
Yeah.
Yeah.
And optimize for
So
like time or space.
yeah, so I think they will I don't know whether this is one design circular queue.
Circular queue. I don't think that's exactly the same. I
Yeah,
think,
this is not the same.
yeah, I feel like, yeah, just, I guess the elevator system is kind of like the way they'd phrase it probably is, so you have an elevator and then, since people can come in and out, they can like input like all these numbers, and then what's the best
Yeah.
data structure to kind of be able to represent it. So like we want to
Yeah.
be efficient. So like I think the answer is just to use a priority queue, where like depending on the behavior of the elevator, you might want to prioritize like going up and down, or like just going to the nearest floor. So in like a nearer floor that gets entered later would go earlier in the priority queue than like the other floors, and then yeah. So I think
Yeah.
it's pretty open ended.
Uh,
But yeah, just being
I
able to
don't know.
discuss that.
Maybe. Yeah.
Yeah.
Maybe I don't understand what a priority queue is.
Oh, do you know what a priority queue? Yeah.
So this guy will explain it in so long. So priority queue geeks for geeks. Let me see what this guy is saying.
Yeah.
So priority queue is an extension of queue
Yeah.
with the following properties. Every item has a priority associated with it. Okay. An element with high priority is dequeued before an element with low priority. If two elements have the same priority, they are served according to their order in the queue. So in the below priority queue, element with the maximum ASCII record will have the highest priority. So C, then I don't understand. CO, then
Oh,
D,
so I
C,
think
D.
okay, there's, so you see they're kind of like sorted alphabetically. So I think that's what maximum ASCII value is. So O gets put in the back like a normal queue, but then since D has higher priority than O because D comes before O in the alphabet, it gets, once it's inserted, then it gets pushed in. The order is COD, but then or actually, hang on, this might not be.
So like he inserts C, then he inserts O, then he
and then
inserts
O
D,
gets put in the box, and then you insert D.
then removes max.
Okay,
So
yeah, and then remove the max element. So you remove O.
that's O.
Yeah.
Okay.
And then you
And
insert
then
I.
insert I, insert N, remove max, so N is removed, and then inserts G. Okay.
Yeah.
So a
it's
typical
kind of,
priority queue. Yeah, go ahead.
yeah. Oh yeah. No, I was just agreeing. Yeah.
Okay. So a typical priority queue supports following operation: insert item and priority. So that inserts an item with the priority, get highest priority, returns the highest priority item, then delete highest priority. Okay. So arrays, a simple implementation to use arrays. Yeah. So yeah, Python.
Yeah. Is
You
that your
are more
language of
familiar.
choice?
Yeah, that's what I'm gonna.
That's good.
That's what I'm
That's
gonna
good.
fight with. Yeah.
Yeah. Hopefully, yeah. With harder data
Yeah.
structures, it might be a little more difficult, but yeah, for your basic dictionaries, arrays should be fine.
Yeah.
Okay, so we're
So
talking about using a heap. That's better performance, I believe.
okay. So heap queue is like an inbuilt heap with Python.
Yeah.
So Python code demonstrate working of heapify, heap push, and heap pop. So yeah, let me get this diagram.
No worries.
So that you want to set television. Yeah, baby, have fun. So yeah, we have like so this guy imports heap queue, and then he creates a list and heapifies it. Maybe I should be doing this. Python, or maybe I should have cleared. So we have import heap queue.
Oh, if you want, I believe Geeks for Geeks supports like you can run it in the browser as well, if you want.
Oh, in the browser.
Yeah. So that
like here.
That could be a bit faster. Some of these buttons.
Yeah, but last time I tried, it was giving me errors or something.
Oh, that's odd.
Yeah, with the file formatting and the how do I call them? The indentation and all that.
Invalid syntax.
Yeah, syntax. So I didn't want to figure out what.
Okay,
so
sure.
Is it? Does he hit q.heapify?
So what data structures do you know? I'm just curious.
I have I've actually done a course. I started
nice.
I studied on it. Yeah, I studied on it last week. So I did this course. I bought this course on Udemy.
Oh, okay.
Yeah, that is structures and algorithms for interviews. So we did.
Array.
Arrays, linked lists, stack, queues,
binary trees,
binary search tree, AVL tree.
Let's go.
Yeah.
Binary heaps. Okay, that's good. Yeah, I think that's a good
binary heap.
Yeah, tries. Okay, yeah. Oh, greedy.
Yeah.
Okay, yeah. This is good.
Yeah, so they did greedy, they divide and conquer. And I'm not done with the dynamic programming bit. I kind of wasn't, I didn't understand. and I think I was tired at that point. So
I see. Yeah, dynamic programming is
just a minute.
Is a beast. Yeah.
Yeah, it's a beast. So yeah, so I think just at the moment when you pinged me for a pairing session, I was going through this, and I thought like yeah, maybe we should have a session. So
Yeah,
I
sure.
haven't done these, but I hope that it's around 2 hours of stuff. So I think I can get time tomorrow and do the 2 hours. But I rushed through this course, so it has graph as well.
Oh yeah.
So yeah, Bellman Ford, all this stuff. I rushed through them, so I'm not very stable, but I can speak something.
Okay. Yeah.
So
yeah. All right. Yeah, sounds good.
So after hippifying this thing, it just looks the same, or does it just convert the data structure to? What does hippify do?
I think
Maybe, yeah. Go ahead.
if I remember correctly, reading up on a heap because it's a little fuzzy for me.
So a heap, what I know is a heap binary tree, a binary heap, where you the binary heap is such that the root is either always less than whatever is on the left or on the right, or vice versa. Yeah. So the heap, if we can have heap that's 4, and the nodes can be 1, 2, or 3. So you can't have like 4 as the root, and then you have a 5 as the and then you have that's when it's a minimum binary heap. Then there's a maximum binary heap where you always have the
it's
root
essentially
always
the
being
opposite.
higher.
Yeah.
No, the root always being lower.
Yeah. Oh yeah. I think kind of remember that. I believe heapify converts with heap. Okay, yeah. I think heapify just enforces the heap property. I'm not sure about the internals of it, but essentially it like makes the thing makes the unordered kind of list into a heap.
Okay.
Yeah. Actually, if you go back to your terminal, let's see. Okay, yeah. So then, let's see. Well, I can't really tell where the root is on this heap, but yeah, I think it's
the root. Okay, I'm not sure. But yeah, but the order change, right?
Yeah.
So we have 1, then we have 3, then we have 9, then we have 7, then we have 5.
Yeah.
Instead of
yeah, I think I think the root is 1, and then its direct children are 3 and 9, and then the children of 3 are 7 and 5, and then that enforces the, I believe, min heap property. Into a heap input in linear time. Wow. Okay. Cool.
Wow.
Yeah. If you wanna, I believe I sent in Google in the group chat. Actually, maybe I should do Slack because it's more permanent. But yeah, I mean, you would read up on the documentation of heap queue.
Yeah. Okay.
All right, and then there's also yeah. Okay, so this is I believe this is the question your friend might have been talking about.
Yep. What question? The one you sent?
Yeah, that's I think in your notepad it was like print an array in spiral form, but I think it's actually a matrix because
Okay,
I'm
just
not
a
sure.
minute.
Yeah.
Oh yeah, I think the guy has hung the phone call. Yeah, someone was calling. So
Okay.
this one, so given a 2D array, print it in spiral form. Anchor. Yeah, so given a 2D array, print it in spiral form. See the following examples. So you have array of 1, 2, 3,
Yeah.
4.
Mm-hmm.
Yeah, so you print it such that it's 1, 2, 3, 4.
And then you go
8,
down
12,
in spiral. Yeah.
16, 15, 14, 13.
Mm-hmm.
And then it
And then you go back up. So 9, 5.
to 5, then
Uh-huh.
6.
You go back in.
Yeah, this is interesting.
Yeah.
This is more interesting than the heap.
Oh, okay. I'm not sure if this is
but
directly a data structures question though, but yeah.
Yeah, I think this is recursion.
Yeah.
Because you can only go left or go
yeah.
down.
Oh.
Then only when you're at the last you go. Yeah. I think this is recursion maybe. Yeah, but maybe we can come back to it later.
Yeah, definitely.
Yeah, thanks. So
Okay.
yeah,
so then heapify makes it a heap. Okay.
Yeah.
And
then heap q dot heap push this for.
okay. So
Let
then
me
now
see
we
what that
put
does.
for. Okay.
And then I can see what li is. So yeah, so it's 1 and the root. The 1 is the root. Then the kids are 3 and 4, and then the kids of 3 are 7 and 5, and then 4, 9. 3, 4. And then yeah, and then so after that
Okay.
yeah, then I think they're asking me to do this. Let me just do that and see what happens.
Okay, that's
so it just prints the same order as the, even if you convert it back to list. And then now heap q dot heap pop.
okay. So now we're trying to pop off the smallest element, so then it'll be 1. Yeah. Okay.
Yeah, but then what's the priority there?
You want to try printing the heap? So okay, yeah, that makes sense. Let's see. I think it's internal because you just imported a heap. So I mean, like, it's kind of abstracted away via if you use a heap queue.
Okay.
Yeah.
So in this case, the smallest item gets the highest priority.
Yes. This is like a min heap, I believe.
Yeah, this is a min heap.
Yeah. Yeah. I'm not sure because because I mean, this is kind of just like we kind of like know the interface of a heap, but we don't actually know the internals. I'm not sure if like Microsoft would ask you to implement like heap queue too, like the internals of it as well.
Okay.
So yeah, I'm not sure if that would come up.
Yeah, sure. Yeah. Yeah, but at least this explains heap queue. What a heap is. What a not heap queue. This explains the priority queue data structure. So implement elevator. Yeah. So implement elevator system in
priority queue heap or something.
Yeah. So I have the following coding to implement the elevator. So public
Java.
class.
Okay.
This is Java.
Yes.
Yeah.
Oh, that's fine. Direction up. Okay, they use a priority queue.
Yeah. So there's the priority queue class in Java.
Yeah.
Maybe data structure. Okay. Yeah, I hate reading Java.
Yeah, it's a little verbose. Yeah.
Yeah.
Or not a little. It's pretty verbose. Yeah.
Yeah.
Oh, system challenge.
With an
Python.
challenge.
Okay.
So schedule elevator to reduce total time taken. Expertise.
Oh.
Maybe this is the question. So given an integer k and an array r representing the destination floors of n people waiting currently at the ground floor. At the ground floor and k. I don't understand this.
Oh,
so given
I think it's saying.
Yeah, go ahead.
Okay. Oh wow, there are a lot of constraints in this problem. Okay, so there are n people on the ground floor. There are a number of destination floors. Takes 1 unit of time for the elevator to reach any consecutive floor from the current floor. Okay, sure. The total task is to minimize the total time taken to get. Okay, so it's just trying to get everyone from the ground floor to the floor they want to get to in minimum time given k, which is integer k. Okay, yeah. So there's n people on the ground floor, and then there's k is the capacity, how many people the elevator can hold, and then the array is the floors. Okay, the floors the people want to get on. Okay.
Yeah.
That makes sense? Yeah, so array is kind of like the list of requests people have. For like it'd be like the pressing buttons, and then k would be the number of people the elevator can hold, and then there are n people total. Okay. Yeah. From the get-go, I'm not sure what we do.
So from the get-go, maybe I want to create a file and call it. You want to close this one, then open this one. and create a file called these guys are going to get me.
There's a lot of ground. But I mean, as long as I mean it's not exactly what you know, but it's kind of like just your thinking process. So always keep that in mind. Always keep talking.
So we have an elevator system, and then we have K. So we have let me just say capacity instead of K, and then say number on ground floor. And then the array is selected floors. And then so we have capacity, number on ground floor, selected floors, and what was there again? So we had an array. Then we had the capacity. Then it takes 1 unit of time to take guys between floors. And we don't know like the highest floor.
I guess it's irrelevant to this question because the highest floor is just the highest request in a sense, I believe.
Okay.
Yeah.
So here we have so they say the task is to schedule the elevator in a way to minimize the total time taken to get all people to their destination floor. So this is difficult. So an input example is 2, 3, 4.
Yeah. And then
K is 2.
Yeah, so the capacity is 2.
And where's N?
N, I think, is just the length of the array. So depending on what language you're using, sometimes you have to specify that. Like I believe in C, you have to specify the length as well to be safe. But I think we can assume it's like the length of the array if we're using Python. Okay. Yeah, I guess, so it's good to start with a small example. So we have 2, 3, 4. Actually, I want to pull it up to geeks for geeks. Okay. So the second and third people get on first run, taking 4 plus 4, and then and then 3 plus 4, first turn taking 4 unit time. Okay, so it has to go up to floor, get to floor 3, drop off that person, go to 4, drop off that person, go back down. So that's 4 plus 4. Okay. And then the person left will take 2 units of time to get to their destination. and then 2 back to go to the ground floor. So that's 4 plus 4 plus 2 plus 2, which equals 12. Okay. I guess we can try first examining like what would be a good algorithm for this. So with 2, and I guess we could also see like why other configurations might not work. So we could try like another grouping, I think would be like 2, 3, and then 4. So then we do, we take 2 and 3 up first. So that's 3 plus 3. And then we'd have to take the person number 4. So that's 4 plus 4. So that would be 8 plus 6, which is 14, which is too much time compared to the minimum time. Okay.
Yeah.
So I guess the capacity also plays a factor in here, definitely. Like if it was 3, then the minimum would just be 4 plus 4. Okay. So I guess my intuition for this is just with capacity at play, I'm wondering if like there's like a basic solution like that we could build up recursively, maybe. So like say if k was 1, then like we would just take the max person, right? Because it takes and then drop off everyone on the way. If k is 2, it seems we take the max 2 people. It's 2 people, right? Because the next group, because the next person we have to take will have lesser distance to traverse. So that seems to make sense so far. So if we do like a 4 plus 3, and then that is the solution, and then we take 2. And then I'm guessing for higher groupings, we just like take the top, like however many. I think that might work. So to implement that, I guess I'll boot it back to you if you think this makes sense.
Not at all.
Oh no.
No.
Okay. What I'm trying to say is like say if k was 1, for example, then like we just have to take everybody, right? Or like take everyone one at a time. And then in that case, it doesn't really, I believe it doesn't matter. Like it doesn't, the order doesn't matter, but like just for like a sanity's sake, say we just take the person highest first, and then the second person, second highest, third highest, fourth highest. So then that would always be the same no matter what order we do it in. But you see, if k equals 2, then I think it makes sense to take the top 2 people first, or group the top 2 people together, because that means we kind of like cut down the amount of time we need for the elevator to go in those floors, you know, because the higher the elevator goes, the more time we'll spend. So we want to minimize those times. So we will, in this case, for example, we want to take 4 and 3. And then like if k was 3, then like we just take everybody and then just go to the highest floor and then back down.
So you mean you want to pick 2 first and then come back for 3 and 4?
Or maybe or I guess the thought is like pick 3 and 4 first because they're the top 2 highest people, and then take 2.
Okay.
Yeah. So I think
or maybe take 2 and 4 and then take 3.
Well, if we take 2 and 4, the issue is I think I was like kind of like looking at the different orderings we could try as well. So if we take 2 and 4, then it'll take 4 plus 4, right? We'll drop off the person at 2 and then drop off the person at 4 and then come back down. But then we'll take, if we take 3 up next, then like it'll take 3 plus 3, right? So that's 8 plus 6, so that's 14, so that's too high. Or that's not optimal. Yeah. So I think my intuition is kind of saying that we need to take the top Kth people and then kind of like group them like that. And then, yeah.
So how does the elevator pick? Okay, on a normal elevator scenario. If the capacity is 2 I thought that guys who are walking in the elevator are random.
I think in this problem, everyone's just waiting at the bottom, so we don't have to like worry about like people like going into the elevator and needing to go somewhere else in the middle.
Oh, okay.
Yeah. So like all the requests come in at the beginning, I think.
Okay.
How do you think what I proposed sounds? Does that sound like it could be?
Yeah. I think yeah, but you know the second example also doesn't make sense. Where
Okay,
they're saying
let's take a
now
look.
they oh yeah, here K
Capacity
is
is 3 now. So then we could just take everybody and just go to the top floor. That makes sense.
yeah.
That makes sense.
Yeah. So our algorithm is to pick from this list. So
Yeah. Let's try to write some comments or something to like get our approach correct. I think it's yeah, £. Yeah.
so that's that now we write create do we need to sort or do we need a pivot?
Oh, what?
Or how do we decide?
Decide.
How do we decide which ones are grouped together?
I think what we need to do is select the top top capacity, like where capacity is the number we can fit in. We need to select the top capacity ones first, and then the next ones, and then next top capacity, and then so on until we're out of people and requests.
Okay.
Yeah.
So that means we need to sort our list.
Yeah.
I
Yeah.
think
At least a starting thing, we should probably sort our list.
So sort the list.
Mm-hmm.
So that will maybe I change this to floors or something. So of course we'll have the base conditions, but maybe we'll write that later.
Yeah.
So
I think I would recommend like fully hashing out the algorithm, fully like discussing the algorithm before like we start coding.
Okay.
Yeah. So then we sort the list, and then what do we do?
Sort the list, and then after the list is sorted, we are going to get the top. The guy is going to the top floors.
Mm-hmm. Like the top capacity or top K in the example. Yeah.
So maximum, maybe maximum guy is going to the top floor.
Yeah.
And then remove them from the list.
Yeah.
And then we have recurse until list is empty.
Yeah. That's kind of like the gist of it. Sounds pretty good.
Yeah.
Let's see. And
But
I guess
we'll also need the base conditions.
Oh yeah, if we're writing something recursive, yeah.
Yeah.
Okay. GF.
So like for example, if we are told that capacity is 0,
yeah,
that at that point we can't pick anyone.
Yeah.
If there's 0 person on the ground floor, we can't pick anyone, and if there's also 0 guys and
well, floors is a list, so if the list is empty, then
so if the list is empty,
yeah. Okay. Yeah.
Yeah.
I believe from my experience in the interviews, it's good to discuss base conditions and then ask if you have to code for them, just because you have limited time. So like if not, like if you discuss them, then it's clear you've thought about them, but you don't have to straight code them like immediately. Yeah.
Okay.
Yeah, but I think the more interesting thing is we're kind of recursing potentially on two kind of like variables, one being capacity and then the other being the list itself. Or actually one depends on the other, sorry, because like we can only like get the top like capacity people up. So yeah, okay. Yeah. I think one helpful thing, if you have the time, is also to like discuss like perhaps an example, like a more complex example that could like test the limits of your like of what you've come up with.
Okay.
So I'm not sure what that would be.
Negatives?
I'm pretty sure that's kind of like an edge case as well. Or yeah, an edge case that we probably don't have to think about, hopefully. And I'm guessing floor 0 is one too. I think we're assuming everyone lives in a floor above. Okay, yeah. But I think what I was referring to is like just having a big kind of example, a larger example than just like take everyone up or like just take like 2 trips,
Yeah.
But I guess it's kind of hard to come up with that because I guess we have an algorithm, so we aren't fully sure if like a pattern would come out from it. It's hard to confirm it, I guess, without like someone actually who knows this question like well. So yeah, I think it'd be good to come up with an example, but then we wouldn't be able to confirm it. So I think it's fine for now.
Yeah.
All right. Yeah. You want to try this out?
Okay. So sort the list, I think.
I believe Python has like built-in sorts or something.
Yeah, so maybe it's list at sort. Are we reversing the list so that?
Yes, I believe so. Yeah, because we want I guess it doesn't matter, but like for clarity, it depends on what you think is more clear. Like whether you're chopping off the beginning or the end of the list.
Yeah.
Oh, also, is this interview? Is it like a remote interview or is it like a on-site or?
On-site, yeah.
Oh, it's on-site. Okay.
Yeah.
So I'm not. So I guess. Have you practiced whiteboarding?
I haven't, but yeah, I think this is part of it. Is this part of it? Like,
I think a lot of companies will have you write code on a whiteboard as opposed to typing. I think it varies by company to company.
Yeah.
But I think just
actually they said on the email that there's going to be whiteboards.
Okay.
Yeah.
Okay. So just one. Oh, sorry. So just one. Oh,
okay.
You go ahead. Yeah. No, it's fine. You could go ahead.
Yeah. I was just gonna say that it's not gonna be a surprise if I'm asked to whiteboard. So maybe what's going to happen is that maybe they told me to practice it and I didn't. So the problem is where I'm at, there's no one I can even practice with. Yeah.
Okay. Yeah. I see. So I think just a tip that I've been given from others is if you're whiteboarding, just make sure you can you can write large and like space management. And also one thing is since you're not in an IDE, you can't just like have things autocomplete for you. So make sure you know syntaxes at least at an okay level, or at least be able to communicate what you're trying to do. But yeah, just that was just a random thought. Okay. Anyway, floors dot sort reverse is true. Okay. Okay. So we've sorted the list.
Yeah. So we've sorted the list. So so how will the list appear right now? So it's appearing like 3, 2, 1. If that's the list, maybe.
Yeah. Yeah.
Yeah. So that's why we are reversing, and then what we do, we pick the we pick the floor.
So we pick the top capacity people, right?
Yeah.
So and that should be the first capacity people in the list.
So current pick equals list. You start with that and get to so you start with this, and so the list is the floor.
Yeah, floors.
And then it gets to the maximum number of guys capacity. Capacity. And then after doing this, you pop floors.pop left, I think. I'm not sure if this is the correct. I'm not sure how to call it twice. Yeah, I'm aware Python has a way to Python list pop left.
I think, yeah, during the interview, if you were kind of like confused about this, that you could just like let them know what you do know about pop, and then hopefully they'll let you by.
Yeah.
Pop 0. Oh, they pop by index. Okay. So.
Yeah.
Oh wait, no. Let's talk about performance differences.
Yeah.
Okay.
So
Let's
I
check
can.
out the docs.
Yeah. So this guy does reverse. Reverse. Oh, so there's a function called reverse, and then list.pop twice.
Okay.
So, but this pop pops from this side. But then I think we needed to pop left. Let me just look it up. Yeah, DQ.
Oh, no multi-pop.
Yeah.
Oh yeah, doesn't seem there's an easy way to pop left multiple times. But okay. Do you know what a deck is, by the way?
A deck? No?
Yeah. Oh.
This is a deck. It's not a DQ. I was calling it DQ.
I think I've heard people call it both. But basically, it's just a double-ended queue. So it's like both a stack and a queue, in a sense. But yeah, just FYI. Yeah.
Oh, okay.
Okay. Oh, well, okay. It seems like we'll just pop or pop left multiple times to like get the right ones out.
Yeah. And I think pop left is also not so. Maybe if I try it here. If I try. What am
So
I
we could
supposed
try like li dot. Oh yeah, or that. Oh, okay. Make a new list, sure.
Then
a dot pop left.
So it's not. I think it's not correct. But if I do the pop, yeah, I think I'll just.
Okay, I see. Yeah. Okay. So I think this is happening because only decks have pop left, because which is kind of in the name because it's double-ended. So right now we can either try to just use pop and then like unreverse the list, or we can try using a deck. Whichever is up to you, I think.
Yeah, I think maybe we don't reverse the list.
Okay. Yeah.
Maybe we don't reverse the list and then we just pop.
And how many times do we want to pop?
For as long as we have for I in I don't know.
Yeah. Capacity, essentially. Yeah. I believe the syntax is range capacity. And that would go in the body of the for loop, I believe. Or oh yeah, list comp also works. Okay.
Yep.
All right. So we pop until. Okay. For now, that's fine. We'll have to like error check that later because popping when there's like not enough elements could be an issue.
Yeah.
But yeah. Okay. Recurse until list is empty. Okay. Here I think I think the problem description said we should minimize the time. So even though I don't think it's a requirement, oh no, it is a requirement to output the time. So we should probably also create a like local variable and then just like append to it as necessary.
Mm-hmm.
Yeah.
So it takes 1 unit of time to get to each floor. So
yeah.
So it will go up 4 and 4 down.
Yeah.
And then it will come and do 2.
Yeah.
And 2 down.
Mm-hmm. Yeah. So then we'd like just, I guess, append. So I guess the easiest way to do that is on the first, like for every capacity element, we would like append to our time variable. So then we probably have to start off like a time variable on top at 0, and then append to it every time we chop the list like that.
So like so current peak. So for so you said we need a variable maybe called time.
Yeah, that keeps track of like how much how long we've spent. Yeah.
Time will be equal to sorry, this guy has come back to me.
No worries.
Yeah, she doesn't know what's at stake.
It's
she's yeah. Clap your hands, mama. So so we are going to calculate the time, where we are going to get the sum of the max floor, max of current peak, by 2. I think it should even be. It should just be this. Max of current peak.
Yeah.
By 2.
So that'll get the current max. Is that your kid?
Yeah. Yeah, she wants to destroy everything.
She wants to be a programmer too.
She
just writing in a different language.
She just needs to get some president to marry, like Melania. And she'll be okay.
Yeah.
Yeah. So yeah, maybe that's enough. That's enough. Okay, Shika. Eat. So by 2.
Yeah.
Do you know what's at stake? So and then
yeah.
And then maybe I'm thinking in this we should be passing the time. So that we are able to we are able to update it across different iteration.
Yeah. I was thinking yeah, depending on where you want to put like the recursive boundary. I was thinking like because because like have like the elevator system is the interface for our problem, we might not want to change it. Just have like time have like sort of like outside the recursive loop, and then be like able to be appended on inside the recursive loop.
Okay.
Yeah, I think that might be slightly better design, and it would make the frames of this function smaller because we don't have to pass time along each frame, recursive frame.
So you're saying maybe we create a, but that will mean we create a similar function like this.
I don't think we.
Or maybe can I create a live share?
Oh yeah. I'll try that. Yeah. So we can communicate better.
Yeah. Because I was just thinking doing this, calling this guy here and saying time equals this, and now the time will be time plus. So this is time plus.
Yeah, plus equals. Yeah.
Yeah, and then now we have the time here is time. So the next time it comes, you add that, and then now the floors will be floors
is
then
the,
it will start with
capacity.
From,
yeah.
We chop it from capacity
to
the end.
Okay. Yeah.
Yeah, but now we are not reversing, so maybe this should change.
So I think wait, we are not reversing. Oh yeah, that's true.
The capacity remains the same.
Yeah.
The number on ground floor is this minus capacity.
Yeah, subtracted by capacity. Yeah.
And then you return time.
Okay. And then we need some sort of base case to break us out of the recursion as well.
Yeah.
But where's your live share, by the way?
I think I should send you this. Sorry.
Okay. Redirecting.
Yeah, it wants you to log in.
Joining Visual Studio. So do I need Visual Studio to run this?
Yeah.
Okay.
You need Visual Studio Code.
Okay. I do have that, but yeah, okay.
Yeah, so you need a live share. You need a live share extension. I don't know whether you have that already.
Oh, okay, I'll take a look for that.
So the live share extension is the one that has the one from Microsoft, and it has like 10.5 million downloads.
Okay.
And all 5 stars.
Alrighty.
And I haven't given my review yet. Maybe I should. Why should I give my review and give them all the 5 stars? And maybe tell them Wednesday that I gave you 5 stars, yo.
Oh yeah, that's true. Same company.
Yeah.
Oh shoot. Okay, have to sign in, huh? Okay. Sorry, I do not use Visual Studio very frequently at all. So I'm just
what do you use? You're a Vima?
For web projects, I currently don't have a great environment set up, so I'm just on Sublime. And
Okay.
then I work a lot in like other languages as well. So I use like if you've heard of JetBrains, I use their IDEs. So
Yeah,
like stuff like IntelliJ and
IntelliJ
PyCharm.
and PyCharm.
Yeah.
Yeah,
Okay.
I get some guys have been trying to push me to PyCharm, but I just keep coming back to this.
To Visual Studio. Yeah, I think it's definitely the most versatile.
Yeah,
But
most Python guys prefer
PyCharm.
This most Python guys prefer PyCharm.
Yeah.
Mm.
Okay. Signing into my Microsoft account. I guess while I'm trying to do this, in the meantime,
I can do the base conditions.
Yeah. But I think before we do that, turn time. Okay. Time elevator system. So it keeps getting reassigned. Yeah, actually, in the base condition, I think is when you have to return time, because otherwise, we'll just keep hitting the elevator system like call, recursive call. But yeah, we can try that. Yeah.
So if capacity equals 0 or number on ground floor, or maybe it's less than 0. Less than or equal to 0, or on ground floor is less than or equal to 0, or length of floors is equal to 0. And then this is return 0. And then there's also that case when the array is none. I'm on ground floor. Yeah, you're in. I can see.
Ooh, okay.
Welcome to Kenya.
Thank you. All right, I'm just okay. Yeah, I'm in, I believe.
Yeah.
Okay, cool, nice.
So I think to avoid you following me all the time, so that when I change files, you also change with me. You can click on this on the VS Code live share, and then click on my name. So to uncheck it, like if I do this, I check so that I follow you, and if I do this, I uncheck.
Hang on, let me try this. Although I don't think we'll be jumping around files too much, but so I just click on the live share, and then I just click your name to follow you.
Yeah, so you can just unfollow so that you don't. Yeah.
Okay,
So
I see.
when you uncheck it, but
I'm not following you. Okay, I see. Okay.
Yeah, I don't know what to do when these guys are none. Maybe I just return, or maybe
zero.
just
Return 0 or
yeah.
Well, actually, I guess logically, if capacity was none and there are people, then it's impossible. So you would just return like infinity or whatever. And then if number on the ground floor is 0, then it's 0. And then if floors is none.
How do you get infinity in Python?
I believe you can do like a math dot. You can either return like an infinite representation, so math.inf if you import math, or you could just return like with computer architecture, you can just return like probably some sort of like integer dot max size or something.
Yeah, maybe I just tell them that.
Yeah, or -1 or something that could work too. Yeah, because that's like a degenerate case.
Yeah. Okay.
Okay, let's see. So if capacity is none, okay, that's good. If capacity less than 0, capacity, okay, yeah, sure. Or number on ground floors less than equals 0, len floors equals 0, return 0. Okay, or and.
Or
I think you want an or, right?
Yeah, I want an or.
Yeah, nice. Sort the list. And then down here, you don't have this anymore, right? No more return time. We haven't written
no more return time.
Or we haven't written the case for return time now, right?
I think in the end we are returning time after all this iteration is done.
Yeah,
and all this addition is done. Yeah.
But we'd have to like break out, right? Because you see, the only way this would end. Can you see my highlight?
Yeah.
Okay, the only way this would end is if we hit one of these cases, right? And then right now we're just returning 0 or -1, so we have to return time. That's in another case, right?
Yeah.
So I think we should talk about the design of this a little more, because it's kind of hard to like distinguish between whether like we are actually hitting an error case or like if we're just finally reached the level 0 and then we want to return time rather than 0 or -1. So let's see. I think so what I was kind of like getting at originally, and why I was kind of like reserved when you were doing this, is because like this kind of forces us to like recurse on this algorithm itself. When I think in this case, an iterative approach might be able to be easier to wrap our mind around. So when I said we should have a time variable, what I meant is we shouldn't recurse directly on this function and instead have like a time variable here. So like we started off at 0 here, and then we do a bunch of stuff to like chop the list until like it's empty, like around here, like here.
Yeah.
And then we return time, and then that would be simpler. Do you think that's? I think that's probably a little easier to wrap our minds around. But what do you think?
Yeah, I think with the iteration, I think it's even faster, maybe.
Yeah. But I guess before we do that, assuming we were able to distinguish between like whether it's actually erroring or whether we actually have the right thing, what do you think the runtime of this is? You bring up performance, that's a good idea. We should talk about that.
Wow. I think, yeah, I think this will run because I think it's recursing. So, what's the general time for recursion? So I will say this this is a constant time operation, and then this is a constant time operation. Sort is a constant time.
Sort is
Sort
actually
can be all log n.
By O, do you mean big O? Or
order of big O.
Okay, it's actually n log n. Yeah, the fastest algorithms, unless for certain, like on average, sort should be n log n, where n is the number of elements.
Maybe merge sort or something, or quick sort.
Yeah. Generally, merge sort, quick sort, those be n log n. Some can be faster on like degenerate cases, or on like good cases, but like in general, the best average you're going to get is n log n. So just keep that in mind. Yeah. Okay. Okay. So constant time, n log n. List chopping. I would have to look that up. I don't quite remember the runtime of that. But since the list is constant, I believe it should be n.
Yeah, constant.
I mean the list, or not constant. Since the list is sorted, I believe chopping off should take no more than n, like linear time.
Yeah.
And then floors.pop for I and okay, this will take. So in this for loop, we'll take capacity because there are capacity operations in
but the pop will eventually, this will eventually pop out all the elements from the list. So I think that's just it will pop like everything. So that's just an order of n. I don't know.
I guess so. Yeah. You're right there. Yeah. Okay. I guess the okay. And then max current pick times 2. So current pick is a list of length capacity. So that'll take max, I think, I'm not sure what the performance of max is, but the worst case is linear in the time of capacity.
Yeah.
Okay. And then we have this recursive thing. So, I mean, you can kind of see that this is a little, I'm getting the sense that this is a little more complicated than we're making it out to be. Just because, well, one thing is, you notice like this thing kind of like waste time because we have a sorted list, right? We already know where the max element should be. But then like the larger issue, I think, is that this getting like this n log n thing in a recursive call is like, it's also hard to calculate. So I think it's in our benefit to try to make this a little simpler before we try running anything. So that's kind of why I said I wanted this time thing here too, and then just return time at the very end, because we put the time thing outside the recursion. And the thing you notice here is that even though our list is getting shorter, we're also sorting it every recursive time. So that just adds runtime we don't need.
Yeah.
Okay. So let's see if we can try to kind of like get this a little more basic. So do you want me to type, or do you have an idea of what you want to do?
Yeah, I think I have an idea what you wanna do.
Okay.
So we have time equals 0, and then we have this is sorted, and then we have while capacity, not capacity, but number on ground floor is greater than 0. And here we'll come and while this is greater than 0, we will pick these guys. And pop them.
Yeah.
And then we'll not have this here. But then we'll have time.
And then since we know what the max has to be, we don't have to use max, but
Oh yeah, we can just pick 0.
Current pick the 0th. Yep.
What's the problem here?
Time plus. I think this bracket here is probably messing with things.
What?
Here. Is that better?
What did you change? I don't know.
There was a bracket down here randomly, but I just deleted it. It's still highlighting. Is it still highlighting for you?
Time equals time plus. Yeah, it's still highlighting for me.
Yeah, same. Can I try something? Okay, so we have a time here. Int expected token.
Unexpected.
Okay.
So maybe it's a keyword.
Oh yeah, that's true. That's very true. Okay, so let's do.
So maybe say
duration.
Yeah, duration.
Okay. Yeah. And then...
But still no. Or maybe we need to get it down here.
Okay, what was it saying? Unexpected token. Duration plus. Oh no! It's because this bracket's missing. Okay. Yeah.
Okay.
So it was down here, and then I deleted it, and then okay, cool, awesome.
And then.
Okay. So then finally we return time. Okay. Or duration.
Yeah, duration.
Okay. Okay, so let's see. We still have some base error conditions. That's good. If capacity is none, number of ground floors none, floors none, then there are errors. If capacity is less than 0 or number on ground floor is less than 0 or equal to 0 or length floors is 0, then we return 0. Okay. Now I guess in this while loop, we we forgot something in this while loop. It'll run forever, I believe, because we didn't update this variable.
Yeah.
So we'll do, we have to do that. So we'll do number on GF minus equals capacity.
Yeah.
Okay. Okay. Now I think it's good right now once the interviewer is kind of confident that you at least have something working. It's good to like go through an example just to make sure that it doesn't like break or you have like random off by ones or something.
Yeah.
So we could try running this, I believe, just to like
but
get it faster. But then on a whiteboard, yeah,
we're not going to run it there. Yeah. So I think first question I asked when I was told that it's gonna be on a whiteboard, I was like, how do you run code on a whiteboard? Do they have like do their whiteboards have like an editor such that like some machine learning algorithm that takes your whatever you write and converts to code? Yeah.
No, I think I don't think I think it's literally just a whiteboard.
Yeah.
And then you have to run examples by hand, so it's harder. It's definitely harder, but
so so what I will do, I will take like I will call this function down here and say now when we come here, so it will first check if the capacity is none or number.
essentially, yeah,
and then it will check this,
mm-hmm.
and if it finds that this any of these condition hold, it will return 0, and then we'll sort the flaws just to get them like sorted.
Get them in the right order. Yeah,
the right order for easy picking.
mm-hmm.
And then have this duration here, and then we loop on the number of guys on the while for while decreasing it until so like for this example, I will just say since the number of ground floor is 3, it will first pick 3 and 4, and then when it picks 3 and 4, it will pop them from based on the capacity. But what happens if it's 1? Meaning we need a base condition for that, right?
Yeah, that's definitely one thing we should definitely consider. Just to make it clear. So we have 2, 3, 4. We popped off 4 and 3, so now we're at 2. The number on ground floor is now 1.
Yeah.
So then we would slice the list on in index 2, which would, I believe, result in a index error or something in Python.
Yeah.
Yeah, because there's only like one element.
Yeah.
Okay. So let's write this kind of like edge case.
That's
it's not really edge case, a fundamental kind of, we have to make sure we're ending correctly.
So here you say if number on ground floor equals 1. If number on ground floor equals 1, then we have we don't even need to get the current pick.
That's true. Yeah. We would just take in the degenerate case, kind of, we just take the guy up. Right?
Yeah, but so the current pick will be the 0th value. Yeah, so we just pop it, close.pop. And then else current peak is that, and then we pop.
And then we yeah, okay. And then duration plus we add up the guy, or we add up where the guy is.
Yeah, but this is so the 0th element of the array.
Well, we just popped off the array, right? So the array is empty. So I see it. So there are yeah, there are a couple ways to do this. I think we could yeah, that's one way. Yeah.
So duration equals
floors the 0th element. Yeah.
Yeah, dot.
Okay, so we can confirm. Yeah, nice.
Yeah.
So with a 2, our time equals should equal 8 at this point. So then let's just go through to make sure it works. So then we get 2. So it equals 1. So duration is going to be added to 4. So then this will be 12. And then we pop off floors. So pop off floors. And then number on ground floor will be reduced by capacity, which is -2. So then number on ground floor will be -1. We might want to make it consistent, but for now this is fine. And then after that we'll hit -1. It's not less than okay. So this works for this example. I think the thing I was thinking here is we may want to generalize this, right? Because like this also happens if like we have a capacity of 3 and there are 2 people left, right? And then so on and so forth, right? So how would we generalize this?
So think of them as odd numbers, like odd versus even.
No. What I'm saying is this. Could happen if like essentially this always happens. In our example, it's 2 in 2, so you can think of them as like if we get odd numbers, we'll always have 1 left over. But like in general, if we think in terms of k, like say if or sorry, not, a number on if we think of capacity. So like say we had not sure what happened there. But say we had capacity equals like 3, for example, right?
Yeah.
And then we had number on GF equals let's say 5,
7.
right?
5, yeah.
Okay, so then that means number on GF would become 2 after 1 iteration of this while loop. And then now we have 2 left over. And then so then you see like this code wouldn't work. I believe since with 2 elements left over, we chop above the list, we chop at capacity 3, and then that would break because there's only 2 elements left. So I think this case should be generalized to if number on GF is currently less than capacity. Yeah. Okay, and then we'd have to like rewrite this too. Or actually, I'm not sure if we have to rewrite this.
Yeah, I think so.
We might not have to. Actually, yeah, we don't have to rewrite this because we'll just pop off the first element, which will be the max. Wait. Oh. Okay, yeah, we do have to rewrite this slightly.
But because what if the number on GF is okay, it's less than capacity, okay.
Mm-hmm.
Yeah, I think that's okay. That's fine.
Yeah. But we have to change this index. Do you know why?
I don't know, but the first index has the maximum value. So
Well,
and we
actually,
haven't popped it yet.
actually, remember pop pops off the right, right?
Yeah.
So if we do this, and floors is not of length 1, like floors is of length 2, for example, we're actually popping off the wrong element.
Yeah.
Yeah. So we have to do like I believe -1 is the way to get the last element.
Yeah.
Yeah. Okay. And then we pop this off. And then duration number on GF would become -1. And then, but that's fine because there are no more people essentially. And then, so that should be good. So that's good. We caught that. Okay. So let's see. You want to try the second example just to see, make sure it works for this as well.
Yeah.
All right. Yeah,
So
we could talk.
how much time have we spent on that? A little over an hour, because they are saying each will be 45 minutes. So.
Oh yeah.
Yeah.
I mean, it's okay. You just make sure you work with your interviewer. Like they'll definitely give you a hint if you're stuck and like, push you along.
Okay.
But yeah, I mean, do you want to keep going on this or?
Yeah. We can keep going on that.
Sure.
So for the second example, it will come in, and on the first instance, it will check the nonce that will not be there, and now it will move forward, and then it will check the capacity, and that will be okay. So we'll first sort the array, and then on the while loop, the number on ground floor on the first iteration is you want to put this for me? So yeah,
what?
so number on ground floor is 3.
Oh, yes.
And then the capacity is 3. So a number on ground floor is not less than capacity, it's equal. And then it will just pick everything in the array, and then it will pop everything from that array, and then it will get the duration of 5/2, which is 10.
Yep.
And then it will decrement the number on ground floor by capacity, which is 3. And that will be 0. So in the second thing, it will like skip the while loop, and then will return 10.
Okay.
Yeah.
Nice. Yeah. Yeah. So it'll work for this. I'm pretty sure we don't have to write like the edge cases.
Yeah.
Okay. I guess we should look at the runtime of this again.
Yeah.
Real quick. So then constant time checks here, and then sorting list still takes n log n. Where n is the number of elements in the list. And then after this, we do a while loop that decrements the number on GF by number on ground floor by capacity. And then, so if we do it step by step, you can see how like it could be kind of complex to count this. But I think the trick is, hello, can you hear me?
Yeah, I can hear you.
All right, nice. But I think the trick is to just know that like in a wider like way, we are sort of touching every element except for perhaps the last few.
Yeah.
So I believe the runtime is probably something like how do you express it? Something like
on the worst case when we have like the number on the ground floor is 1 and capacity is 1. So in that case, the while loop will be n, the time to run.
Yeah.
Yeah.
And specify what n is.
N is the number of guys on the ground floor.
Nice. Yeah. Okay. So then, and then assuming number of guys on the ground floor is equal to the length of floors, the runtime overall of this thing is n log n plus n, and then because we're looking at asymptotic like runtime here, we only take the max term, so it's n log n.
Yeah.
Okay. Let's see. At this point, I don't have anything like. I'm not sure how to intuitively like make this better. So we can try going back to Geeks for Geeks and maybe checking if there was something we like missed or like something we can do to do better. What I suspect is there might be like if we use a priority queue or something, or like maybe use another data structure, we could like push it a little faster, but I'm not sure if that actually is the case. Okay, def min time nka. They sort in descending.
Yeah, they sorted it with the reverse.
Oh, okay. They did something that was smart. So I see they're iterating up by k. Okay. And then update the time taken for each group. And then okay, so they're skipping up each k elements and they're sorting it in reverse order, so they essentially can do that. Okay,
okay. I don't. So in the for loop, they are going from 0 to n in k. So in space of k.
Yeah.
So
wait. Hang on.
So it will go from 0 if n is if k is 2 and n is 3. Yeah, they're saying n is the length of array. So if n is 3, so they will count 1. Does it start from 0? The range, yeah, I think it will start from 0. So it will be 0, and then from 0 it will skip to 2. And then 4.
Yeah, that's how it works, I believe.
And then it gets mean time. So it gets the 8th element. Yeah, so it gets 0, then 2. Then yeah, so they don't have to slice the array. Yeah.
Actually, there might be a bug here. Hang on. But essentially, I guess before I look at that, yeah. So
yeah, maybe they should break it after k is bigger than n. That should be the base condition here. After k is bigger than, or after 0 and k, or 0 to n. Yeah, I don't think it gets there. I think it breaks on its own. Yeah.
So this isn't quite right, but yeah, I think another issue is if you sort a dot sort reverse and then increment up every k elements, Sort reverse. So then, like, say we did like 4, 3, 2, and then oh no, never mind. Sorry, that's correct. That's correct.
Okay.
Yeah, actually, sorry. I think. Wait, what was the bug you think you found?
Nope, I didn't find any.
Okay. Yeah. So just to be clear, so then they sort in reverse. So then 4, 3, 2 comes out, and then they jump up every k elements. So if they start at 4, they go to 2. Yeah. Okay. That's good. Yeah, this is a little more nifty than like just chopping up the list.
Yeah.
Yeah. Yeah. And also, like, when we chop up the list and pass along copies, we have to like think about space concerns as well. But yeah, time complexity n log n.
N log of n because of the sort.
Yeah, the sort is the limiting bottleneck.
But how about this? So the sort, since the sort is log of n.
Oh, yeah, n log n. Yeah.
But this is n log n plus n, because this, a case where this is 1 and this is 10, this thing will go 10 times.
That's the worst case.
Yeah, that's the worst case.
Yeah, I think you can precisely do it, like precisely express it probably as like n over k, like ceiling, I think.
Yeah.
Because it's just going like essentially going up to n like k time, like skipping every k elements.
Okay.
Yeah. But either way, that is less than n log n if k is an integer, positive integer.
Yeah.
Okay. Yeah, I think we were pretty close. Yeah.
Yeah.
That was a good one.
Yeah.
You want to keep going? I'm totally down.
Yeah. Yeah. Maybe I take a short break. I reply some private Slack messages and then.
Okay, sounds good. Yeah, I will too. All right. Yeah.
Okay.
Good work. Yeah.
Okay. Thanks.
Yeah. See you in a bit.
No. Hi, Clement. Hello.
Hello?
Hello.
Hey, Mike.
Hey.
Good morning, good morning, good morning to you. Good morning, Mr. Bruce.
You good?
Yeah. I will be trying
Alrighty.
to fit this guy.
Oh.
Short space of time that he gets.
Uh-huh.
Yeah.
If you want, you can take a couple more minutes. It's around lunch in my area, so I could like heat up something real quick.
Oh, okay. Nice.
Yeah. Okay, sounds good. All right, see you in a bit.